Redox titration. The learning objectives for this lecture is you should be able to recognize redox reaction, discuss redox titration, and also to be able to calculate an unknown concentration. Redox reactions is actually oxidation and reduction reactions. The short name is redox. What is redox reactions? To understand this reaction, we need to understand the term. What is oxidation and reduction? Oxidation is said that when you lose one or more electrons, the substance will be oxidized. Reduction is when you gain one or more electrons and the substance will be reduced. Therefore, an oxidation reduction or redox reaction is a process in which electrons are transferred from one substance to another. Looking at this reaction, how do we know who has been oxidized and who has been reduced? To identify who has been oxidized and who has been reduced, we need to look at the oxidation number. Therefore, you need to assign oxidation number to each of the substance in this reaction. Calcium has 0 oxidation number, hydrogen ions +1, and after the reaction, calcium has a +2 oxidation number and hydrogen is 0. So looking at the definition, for calcium, you can see that the oxidation number changes from 0 to a +2. This means that calcium has lost electrons. From the definition, when a substance loses an electron, it has been oxidized. For hydrogens, the oxidation number changed from +1 to 0. This means that hydrogen has gained electrons. From the definition, gaining electrons means the substance has been reduced. So as you can see, in a redox reaction, one substance must be oxidized and the other substance must be reduced. This is another example to identify which substance has undergone oxidation and which has undergone reduction. Again, you must first assign the oxidation number. For iron, it's +2. After the reaction, oxidation number for iron is +3. As you can see, that iron lost 1 electron. Therefore, iron has been oxidized. For chlorine, on the other hand, oxidation number 0 and -1. the oxidation number has changed from 0 to -1. This means that chlorine has gained electrons, and gaining electrons means chlorine has been reduced. You can try this example by yourself. Which reactant is reduced and which is oxidized? This would be your answer. Tin is oxidized and iron is reduced. Now you have understand what oxidation and reduction reaction is. In a redox reaction, there are oxidizing and reducing agents. Reducing agents are agents or substance that will cause reduction in other substance. It itself will lose one or more electrons. It itself will undergo oxidation, and it itself will increase in oxidation number. Vice versa to oxidizing agent. It will cause oxidation in other substance. It itself will gain electrons. It itself will undergo reduction, and it itself will decrease in oxidation number. From our previous example, for chlorine, it has gained electrons and it itself has undergone reduction, and the oxidation number decreases. So it is an oxidizing agent, which causes oxidation in iron, making iron the reducing agent. You can try this yourself using the equation from the earlier example. Which reactant is the reducing and the oxidizing agent? And the answer? Iron is the oxidizing agent and tin is the reducing agent. That is what redox reaction is. Now looking at titration, titration would have a burette containing the titrant and a flask containing the solution to be titrated with an indicator. Titration method can be used to calculate unknown concentration. Titration starts with adding known concentration solution into the solution to be titrated. It will slowly be added in increments until a color change, and we can calculate the unknown concentration. So redox titration uses redox reaction. The reaction is complete when there is a color change. In most cases, reactants usually react as indicators in this type of titration. For example, potassium permanganate, where potassium permanganate acts as the titrant and as the indicator itself. The titration starts with the potassium permanganate of known concentration with a solution with unknown concentration. The titration proceeds as potassium permanganate are being reduced to colorless until the end point where potassium permanganate is no longer being reduced. This means that the reaction is complete. Iodine can also be used as a titrant. However, when you use iodine, you will need to use starch as the indicator. You start off using iodine as the titrant, and when you reach endpoint, when all the iodine will then start to react with starch. Excess iodine will react with starch, turning the solution into blue. This is when you know the reaction is complete. So redox titration is actually straightforward and easy. So the application is as such. For example, in this problem, where we use 4 molar of potassium permanganate, we used 25 milliliter with 100 milliliter of iron solution, a solution containing iron, but we do not know the concentration. Therefore, to calculate the unknown concentration, we need to look for the number of moles in 25 milliliter of this potassium permanganate. We can use this formula to look for the number of moles of potassium permanganate in 25 milliliter. Therefore, from the calculation, 0.1 moles of potassium permanganate in 25 milliliter of potassium permanganate. So from the reaction, 1 mole of potassium permanganate reacts with 5 moles of the solution containing iron. Therefore, if 0.1 mole of potassium permanganate react with unknown number of moles for solution containing ions, when we do the cross multiplication, we will get the unknown number of moles of the solution containing iron. Therefore, from our calculation, we know that 0.5 moles of iron has reacted with our potassium permanganate. So now we can calculate the unknown concentration using the same formula, and our unknown concentration of iron is 5 molar. That is how you calculate an unknown concentration of an analyte using redox titration. These are the other problems that you can try at home, and we will discuss it in class.